Hi, welcome to Analytics for All. This is the first lesson in our third module here, our Python for Data Science course. This lesson is entitled Central Tendency and Intro to Stats. Third module is going to be based mostly around statistics and visualizations before we go ahead and get into machine learning in module 4. Now, I'm not going to get really deep in statistics. I'm going to go over some important functions you guys need to understand. I'm not going to drive you down into the math hard into it. I do highly recommend if you're serious about a career as a data analyst or a data scientist to pick up some statistics books. I mean, even the board dummies books are really good at this. The 1 and 2 stats courses. It should give you enough knowledge to really kind of at least get your feet wet and moving in this. Uh, this central tendency, if you're not familiar with this concept, it's a way of looking at a large group or a large sample and identifying it in a single number or value. Uh, and that's really statistics is all about it with sampling data, setting up experiments, all these different things, looking at a larger population and understanding more about it. And I think there's so much value in that, especially when it comes to setting up experiments when you're doing machine learning modeling. If you don't have a good basis for how to do it, you're going to fall into some traps, and a good grounding in statistics will definitely help. Let's go ahead. Let's pop over to my website. Now, as with all my lessons, I have a full write-up on my site, analyticsforall.org. This one I called it Python Fun with Central Tendency because I wanted to play around a little more than just, I mean, we could do all this with just some simple functions in NumPy, but I decided and said, let's have some fun and let's build out our, our values. So we're going to learn this one. We're going to learn mean, median, mode, and we're going to learn about quantiles, okay? If you're not familiar with these, we're going to go over them quickly, and we're actually going to learn the math behind them. It's very simple. It's nothing more. You don't need to know anything more than how to add and divide. Nothing too advanced here. Okay, so here we have our notebook, our Jupyter notebook. Again, I said we're going to go ahead, and if you're not familiar with these terms, let me take 2 seconds and kind of go over them. So we have mean, which most of you will probably recognize as the word average, but if you ask any statisticians out there, they're going to let you know that all of these are averages. You know, an average is just a term that looking at a value. And you would want to learn things like average because it kind of gives you an understanding of an area. So like, let's imagine we took the weight of every student in a high school for 10 years ago that we did it again this year. Would you want to look through a list of hundreds and hundreds of hundreds of weights to try to see if you see anything out of it? Or if I told you, hey, the average weight increased 10 pounds in the past 10 years, doesn't that mean that's a really quick, concise way to look at a population and understand what's going on? And that's the phrase we use. There's a population and a sample. A sample is actually, instead of looking at every single person in the population, we can take a look. If we looked at a school, as long as we did a fair sampling, a completely unbiased sampling, if you had 500 kids in a school, and I only took the weight of 50 of them really to kind of get a good mean average around there and good sampling bias. And we'll get more into sampling stuff later, but just so you understand the terms, you're going to hear population and sample. That's what I'm talking about if we just look at it. And so I've got a list here. And again, we're going to go into median, mode, and quant. I'll explain each one as we go in turn. We got a list here of numbers. And I want, I just made up these numbers, but let's go ahead. Let's say these numbers represent the ages at a family get together. Okay, we just took the ages of family get together, and there's 19 of them here. If you go quickly run the list and show the list. So I want you to sit there and I want you to imagine there was 100 people and I just grabbed these 19. This would be my sample size. When I say sample, that's what I'm talking about. This is what my list is. We got 19 ages of people at a family party. All right, so for the mean or average, we're going to add up the math behind it is we add up all the values and divide the number by the number of values there. So by the number of values or sample size, okay, which would be 19. The length of our list is put in other terms. Okay, now I know I've shown you in the past with NumPy how we can do this with just using NumPy's mean feature, but here we're at, instead of just using that, I want you to build out the function so we just learn how to do it. So we're going to make a function called myMean. It's going to take in one argument, which is going to be our list, and we're going to set this z0. That's how I'm just setting z to 0 so we can always start it. We're using z as our placeholder to count, so we want to keep it started off at 0. N is the length, which is the length of the sample size. N, you're going to see in all statistics, that's your sample size number. It's the number they use. You'll see N always used as sample size, so just use it as good practice. And for y and x, so for y and x, which is the list being sent, I want you to iterate through each value and add it to z. Again, z starts at 0, then we keep adding, adding, adding. Then finally, we're going to take z when it's totaled up, divide it by n, and return z. So that would give us our main list of 13. Now, it's returning 13 because I used 2 of these division signs. If I do this with 1, it'll return the value with our, it will return value with decimals. I had a brain fart there. All right, we can also do it. Let's make it a little simpler. Let's go with my mean x. All we have to do is say is return sum divided by length of x. So it's the same thing up here. We don't have to use the loop though, because sum's already a function that does that for us, and it gives the same value. Okay. Now the next one we're going into is median. That's where I have this set up. I've got this list here, and I want you to imagine these are all salaries in tens of thousands of dollars. So 75,000, 88, 68,000, 90. All right. And it returns 78, which is, kind of makes sense for that population there. Now let's imagine suddenly Bill Gates is in the list and he makes 100 million a year. Now look what happens. We're up 17, 1.7 million suddenly becomes the average. We know that's not correct. We know that these people haven't suddenly made that much more money. The average person is not making 1.7 million. We just have this one giant outlier, i.e. Bill Gates, pushing that. So how do we get around it? We get around it by doing the median. So what is the median? Well, the median works by, first of all, you have to take a sorted list. So we take these values here, 68, 75, 77, what do I have? 80, 90, and then this massive Bill Gates number. All right. So what that gives us, what in the median tells us is we count 1, 2, 3, 4, 5, 6. So we have 6. So we have 6 values there. So what we want to do is we're going to take the 2 middle numbers in the sorted value. Remember, it has to be sorted. You can't just use it the way you have to sort the values first, add them together and divide them, and that'll give us our median. If we only had 5, it would just be the simple number. It'd be the middle number here, 77. So, but you'll notice the 7780, that's going to give us a number closer to 78. It's not going to give us a 1731 like we had here. So the median is not so much affected by these outliers, and that's where you'd want to use median. So how are we going to get there? So let's go ahead, we'll come back up there. Let's create our own function here. And we're going to say my median, x, that's the list. Going to take n as the length again, sample size. And we're going to say midpoint is n divided by 2. And again, //2. It's going to give us the value, so there's going to be no decimal point at the end. And I'm going to say if n modulus 2, if you remember from my earlier lesson, modulus 2 is a remainder. So if it's an even number like 10, 6, 4, it's going to come back 0 because there's no remainder. An even number divided by 2 has no remainder. 3, 7, 5 will return a remainder of 1. So if it's 1, it's an odd number. And we like odd numbers and medians because we just got to pick the middle number. So all we do is we sort the list and return the midpoint. If it's not, we have to return, if it's even, we got to get the midpoint plus the midpoint minus 1, get their values, and just add them together and divide them by 2 and return that. And that gets us our median. So we go through our list here, median 9. You know, it's 9 versus 13, but when we go up and look at our list is very stilted towards on smaller numbers. There's a lot smaller numbers than there are bigger numbers in here. So that shows the skew, which we'll worry about skews later when we get into like distributions and stuff. But for right now, just know that that kills skew. And also we do the median now to my list I created. It's 78.5, which is much more representative of what these people are making than what this mean does, because that one just throws the skew off so bad. So that's median. Now we'll go into mode. Mode is, you don't see it as often, but it's very simple. Mode returns is the most commonly used value. So if you look up here, you can see that like 7 appears twice here, 3's appearing a few times. Which one appears the most in the list? So to create mode, we're going to bring in counter from this library called collections, and we're going to put the list to the counter, and we're going to return the most common value. And see here what it does, it gives us tuples of, so 3 appears 4 times, 7 appears 2 times, 9 appears once, all the rest of them appear 1 time. That's what it gives you. It gives the number, the most times they appear. And if I put 1 inside the brackets here of most common, it's going to return the value that's the most common there. Okay, it's the one used most. So I can make a quick function, my mode, bring in one value, return D most common 1, and that will send my list to it. Okay. Now, we're going to go ahead into quantiles. Now, I've heard of quartiles, where quartiles, the first quarter, third quarter, we break things into that. We're going to break into quantiles. So what we want to do is we want to see, instead of just being limited to 25, we're going to break it in any way we want. So what 10%, 25, 35%. So let's go ahead and we're going to create another function with an x and a y. And I want to return the integer of y, which y will be the percentage we want, 10%, 35%. It's going to be a decimal point. And we're going to multiply that times the length of the list. So up here, this is what we're trying to do here. And that's going to return 6.9, but it's going to return 6. It's going to return an int of it, so it's not going to have a decimal. So let's go ahead and fix that. If I could type correctly, this would be so much easier. There we go. And 6. So it's going to return 6. So that gives us our. So we're going to say now if the y is greater than 5, what we're going to we're going to return these sorted lists. Now with a sorted list, if you remember slicing here, so I've got a sorted list. So I'm going to sort it. Oh, he starts from the ground zero, and I'm going to say 0 to 4. So this is going to return the first 4 values on the list. Or I could do this. And this will return the last 4 values, or anything after 4. See, that goes, it gets 0 to the first 4 and counts everything after it, So if I wanted the last 4 values, I'd actually have to probably go up to what is it, 16? Close, 15. All right, that returns the last 4. So anyway, so here we go. So we're going to say if it's greater than 50, we're going to if it's greater than 50%, I want you to return the sorted list, the last, go up to that value and give me the last values on the list. If it's before, I want you to give me all the list up to the value being given. So, and the value comes from the indicator we get, which is our percentage times our length. So 35%, it would be the first 6. So if we ran this list at 35, let's run the function, and it'll return the first 6. If I ran it at 10%, it's going to return the first 1. And if I ran it at 75%, now keep in mind 75 is going to give us the last ones, it's going to return 14. So it's going to go the 14th on the list, so it'll return the last 5. Okay? So that's quantile, median mode, and more than, again, all this stuff you can do with a simple function out of NumPy. You don't have to actually build these yourself. I just wanted to show you how to build them. Let's use a little bit of our programming skills we're learning. Okay, in the next lesson, we're going to go into frequency distributions and histograms, get into some more visualization tools, that kind. We'll build upon each one of these. Again, I'm not going to get deep into the math. You don't have to worry about calculus or linear algebra or anything here right now. If you like this lesson, go ahead and hit the like and subscribe button. If you want, go ahead and leave a comment. I build videos for people based on I've built plenty of custom videos. As long as it's in the realm of data science, whether it be Python, statistics, visualizations, even Excel, I'll be more than happy to make a video for you. Also, please visit my website, and thank you very much. Hope to see you again.